So hello everyone, in this experiment we are going to see the simulation of three-phase PWM inverter. So what is a PWM inverter means? An inverter whose function is depending upon the pulse width modulation technology. This is referred to as a PWM inverters. So these are capable of maintaining the output voltages as the rated voltage depending upon the irrespective type of load connected to it. So the main objective of PWM is to control the inverter output voltage and to reduce the harmonic content in the output voltage. So the pulse width modulation techniques are mainly used for the voltage control. So these techniques are most efficient and they control the drives of the switching devices. So here we can see three-phase PWM inverter. So normally we know that a three-phase inverter we are going to give the 6 switches, that is here going to take the IGBT switches. For each switches we are want to give the gate pulse. So in this circuit we are going to design for 6 switches. The gate pulse is given from the sinusoidal PWM generation. So we are going to create the sinusoidal PWM in the circuit, and from that sinusoidal PWM we are going to give the gate pulse. So for this purpose we are going to use the go to as well as the from operation. So from this go to operation we are going to give the signal from the R wave, Y wave and B sine wave. So from these 3 sine waves we are going to give the gate pulse. From the go to option, the sine pulses are given to the IGBTs from this from option. So let me see how we are going to connect the circuit diagram. So we are going to start with the continuous power guide with a DC voltage source. It is a inverter. So we are going to convert the DC voltage into a AC voltage. So DC voltage we are going to give the 100 volt. Then 6 IGBTs. So for 6 IGBTs we are going to give the 6 pulses from the separate from the RYB sine waves. For this operation we are going to use the 3-phase VI measurement. So you are going to measure the 3 voltages from this scope. So you are going to use the DMUX operation to see the output voltage of VABC from this scope. Then for the load we are going to give the 3-phase parallel RLC branches. So for 3-phase PWM inverter you are going to use the 3-phase load. So we are going use the 3-phase parallel RLC branch, and then you want to ground it. So this is this part is your 3-phase inverter. So for this inverter you are going to give the gate pulse. So for gate pulse generation we are creating this circuit. So we are getting the sine wave. So I am going to give the sine wave to the adder. So this is your logical operator. So you are going to adder operation to this. We are going to give the adder. So from the adder you are going to compare the output from the sine wave. So you are going to compare and greater than or equal to 0. Then that output will be given to the switch one, that is your go to option. So this go to option will be given to the from. So here it will go, and from the from you can get the output from the R sine wave. For like this you want to do the for the Y sine wave and B sine wave. So this is your sawtooth generator. So here you can already study, that is sinusoidal pulse width modulation. You are having 2 waves, that is normal sine wave, that is your reference wave, as well as your carrier signal wave. So in this we are going to give the sawtooth generator as a carrier signal, and normal sinusoidal wave is for 3-phase you are having the RYB sine wave. So for we are going to compare both the sine wave with this sawtooth generator. Then from this output we are going to give the taken the pulses, that pulse with this given to this IGBT gates. Okay now. So here we can see the RYB output, then the sawtooth waves through this scope. Then the output while comparing to this logical operator not, then this output can be seen through this scope 2. That is by comparing your carrier wave as well as your sine wave, how the pulse widths are getting corresponding to this function. We can see the output through this scope 2. So once connecting all these circuits, we are going to save the simulation. So after save the simulation, you want to run it. So it's finished running. So now we are going to see the output. So here we are going to see the scope of the voltage, that is output from your VABC. So here we can see clearly. How we are going to see here. Here we can see clearly your R, Y and B phase of the voltage 3-phase measurement. Next we are going to see the RYB sine wave with your sawtooth generator. So here we can clearly see your RYB with your sawtooth generator. So this is your sawtooth generator. So here we can see your sawtooth generator pulses corresponding your RYB phases. Then in the third scope we are going to see how your R sine with a corresponding sine as well as your sawtooth generator. We are going to compare with the R wave and your carrier signal and your reference signal. We are going to compare and we are obtaining a pulse width. So this can be seen in this scope. So this is your sawtooth generator. So here we can see clearly that is your sine wave. So corresponding sine wave with your reference signal with the carrier signal, your sawtooth generator. So while comparing with the sawtooth as well as your sinusoidal wave, we are obtaining your different pulse widths. So these pulse widths of operations will be given to your gate of your MOSFET. So this is the pulse width generation. This is your sinusoidal pulse width generation. So now you can clearly understand. So thus a 3-phase PWM inverter is verified using a MATLAB simulation successfully. Thank you.